Hello everyone, my name's Sarah. I actually just graduated in chemical engineering this past year, and I'm just super excited that you're interested in Clemson chemical engineering. And so in this presentation, I'll be talking a little bit about what chemical engineers do, as well as some of the opportunities that you would have specifically at Clemson as a chemical engineer. So first of all, I just wanted to give you a brief overview of what is chemical engineering, what makes it different, what makes it special. So first of all, it kind of combines all these core sciences, so like chemistry, biophysics, and math. And so for me, when I came to Clemson, I really knew I enjoyed chemistry and math, so I thought it'd be a great fit for me, and it was. So that was pretty good. So most chemical engineers work through synthesizing material from a reaction, then they might engineer and process it a little bit, and then ultimately they purify it for end use. So that's kind of like a broad thing that most chemical engineers will do in common. But however, chemical engineering is a super broad field, and we're going into more of that in the next few slides, but it can actually prepare you for a wide variety of career options. Here are some of the careers in chemical engineering, and as I go through them, just ask yourself for any of these careers that I would see myself enjoying, because ultimately that's the goal. So for commodity and specialty chemicals, here you could think about catalysts, paints, cosmetics, polymers, detergents, so these kind of things. And chemies working in this field often will work with extracting, isolating, combining various chemicals to obtain a desired product. So for energy, some examples of this, which is also a very large field, could be making gasoline from crude oil, or converting used cooking oils to diesel fuel, developing materials for fuel cells, even converting corn to ethanol. So again, there's another wide range of opportunities in this field as well. Now, for electronics and advanced materials, for example, you might work on designing semiconductor materials for computer chips. You could work on optimizing reaction conditions and reactor sizes. Ultimately, you might work on better dissipating heat and methods to operate faster. So a lot of optimization in this field as well. Now, for environmental sustainability, you could think about finding synthetic replacements for natural materials, processing wastes more efficiently, developing new recycling technologies, even producing safe drinking water. So again, this is just kind of a broad overview of some of these, and we'll go into some more careers in the next slide as well. Okay, so for biotechnology, some examples for this one could be developing new materials and devices for controlled drug release. Also, you could work in tissue engineering or glucose monitoring in diabetic patients. You could work on membranes used with artificial kidneys. And some people even work with using living cells to produce chemicals like antibiotics and insulin. So if you're kind of thinking in between bioengineering and chemical engineering, this could be a route for you. Now, as for food technology, you could work on improving food processing methods. You could work on making more effective chemical fertilizers for more nutritious foods. And you could also work on, for example, increasing worldwide food production through working on hybrid plants that are insect resistant. And then finally, pharmaceuticals, another pretty large field. It's also pretty popular among our chemies. But in this one, you could work on, for example, mass producing drugs to make them both cheaper and safer. However, you don't have to stay in chemical engineering, and that's one of the really great things, again, about this major is that it can be used as a stepping stone for other things. So about 10% of our grads in the past have worked in a medicine-related field, and some have gone on to become doctors, some PAs, and some even will get their advanced degree in engineering and then do research with some of these doctors to develop materials for medical use. And I'll just say for me, actually, I'll be going to medical school this fall after having graduated. And so, yeah, it's been a really cool way for me to use chemical engineering as a stepping stone for medicine. Now, as for law, often our grads who want to go into this go into patent, environmental, or business law. And I'll say we generally have about one each graduating class who goes to law school, and there is one chemie from my graduating class, actually, who is accepted into law school for the fall. And some chemies also decide to go more into the business route. So in this, they might pursue management leadership positions. And for chemies who are more interested in this, we actually offer business as an emphasis area. And I'll be going into emphasis areas later on in the presentation. And also for some of those chemies who want to go into grad school and then do research, Some go on to do research in industry afterwards, some go on to do research at public universities, and then some go into academia and they might teach at a public university as well. All right, so these are the stats from the previous year's class, but 80% entered full-time employment and the other 20% continued academic preparation with grad work in engineering, medicine, or law. Now, I will say this again was before the coronavirus because it was the previous years, but I will say even in my graduating class, the majority of the students have not lost their jobs due to coronavirus. That's been really, really. And I also just want to tell you a little bit about some of these advanced career opportunities. So for example, you could get an advanced degree in chemical engineering, and actually about 10 to 15% of our grads in previous years have done this. So PhD, you would normally do 4 to 5 years of research at a university, and then some after that will go into industry, and they'd often do research development, and then some will go on to teach at universities and often continue their research there. And also some will get a master's, and this is normally 1 to 2 years of research at a university before you would get your master's. And most people would use this book to become more specialized in a field that's related to engineering before going into industry. All right, so we actually have about 5 to 10% of our grads who pursue professional degrees, and so this would include medical, dental, veterinary, and law. Some of our grads also, 3 to 5 years after graduation, would pursue an MBA. So this is short for a Master's in Business Administration. And they would generally do this to advance their career within the corporate setting. So think about if they want to go into management, that kind of position, that kind of role. And we also have some grads who get a professional engineer certification. And so this would be based on 5 years experience as well as a professional exam. Then you would need to be recommended by also another professional engineer at your company. And so this would allow you to offer services more directly to the public. All right, so again, just a quick disclaimer, this was made before the coronavirus. So of course it's a little unknown how some of this might change, but according to the Sloan, according to the US Department of Labor, that chemies are expected to see employment growth in the foreseeable future. And also, large growth opportunities are really expected in energy, biotechnology, and nanotechnology, and more the research and development side, as well as in energy, specialty chemicals, and pharmaceuticals, and this is more along the manufacturing side. All right, so I hope that all the previous stuff was kind of just a good overview of what chemical engineering is, what you could do with a degree, what you could do with a chemical engineering career. And so now we just kind of wanted to just tell you about what makes chemical engineering at Clemson so special. So first of all our courses and our labs are in Earl Hall, and it's just us. So it's kind of nice that it's just kind of like, this is our building, this is our major, and everyone you see is a chemical engineering major. Just kind of nice little community that way. So there's about 200, 300 undergrads in our major, and now these don't include freshmen in this number, and that's because freshmen are considered general engineering and they don't declare what type of engineering they are until the end of their freshman year. There are also about 60 grad students and about 20 faculty and staff. And I know it sounds super cheesy, but we're all one big happy family, in that I'd say we're a small enough major that you get to know a lot of your classmates over all 4 years. And then we also just do so much group work that we're just used to getting help from each other. And it's like, I always felt like I could ask any of my classmates for help on anything. And that's just a really, really nice learning environment and community. Yeah. And we also just wanted to tell you a little bit about the curriculum and what are some of the classes you might be taking as a chemical engineer at Clemson. So freshman year, you can see it's mostly just kind of these core classes. And the only big difference is that final one, that intro to chemical engineering. So every other engineering major takes MATLAB instead, but instead of MATLAB, we take this class where we kind of start learning the foundations of chemical engineering, and we also do a little bit of programming in Visual Basic and Excel. a lot of reactions, mass balances, that kind of thing, just to kind of get your feet wet in chemical engineering. And so that you would take this the second semester of your freshman year, but we also do offer over the summer. So for example, if you were kind of not sure whether you wanted to do chemical engineering, you could take it over the summer if you so decided to. And then sophomore year, you can see there's a lot of chemistry, a lot of math, also a lot more of these foundational chemi courses. So you can think like energy balances, thermo, and fluids, for example. Then junior year, as you can see, more chemistry, also a basic electrical engineering class. So that's kind of cool just to give you more exposure to that field as well as a biomolecular engineering class. But then a lot more chemical engineering classes as well. And the big one I would say here is our unit operations lab. And so this is the cornerstone of our curriculum. It's 2 semesters long, so you would take the first one the second semester of your junior year, and then the second lab the first semester of your senior year. So it kind of builds on all the thermo and the fluids and those mass balances, separations, all of these classes that you took earlier. It kind of puts them all together into one class. And so you have a faculty advisor, and then you work in teams of 4 students, and your faculty advisor will give you a task, and then you have to write a procedure, you have to identify safety hazards, you have to determine all your calculations, figure out your objectives and methods, do a literature review on existing literature, and then you have to submit this and have it approved by your faculty advisor all before you go into lab. And so after that, then you're allowed to go into lab. And in lab, you learn to think on your feet because things will go wrong. But as a result, you can learn to troubleshoot. You learn to really kind of think as an engineer and be like, okay, so what have I learned that could be explaining why this isn't working as I expected it to? And so then you might have to revise your procedure and change things. And you really just grow and develop as an engineer through this lab. And so some of our grads have actually said that this lab is what helped them the most in industry. And some of the faculty who lead this say that this is where our students go from students to engineers. So that's all pretty cool. And then senior year, as you can see, there's more chemi. You would also have a second semester of operations lab. You'd have that another biomolecular engineering class. But the big one here, I would say, is senior design. So our design project is to design an entire chemical plant with a team of 4 students. So you would have a faculty advisor, and you would update them. Some prefer it weekly, some prefer it monthly. But this is overall your chance to put everything you've learned in chemical engineering together into this one final design project. And so you would have a final presentation and a report at the end of the semester that you would turn into your advisor. And yeah, some of the projects that I've gone to work on have been super cool. So mine with my group was working on converting soybean residue to ethanol. And so it's just pretty cool that you get to think about like all the necessary processing steps and how are you going to figure out all the reactions and everything that goes into ultimately starting with the material, using a reaction to create something else, and then purifying it for end use. Okay, so this biomolecular concentration, so if you're between chemical engineering and bioengineering, this is for you. So freshman year, there's no changes. So that's kind of nice in that you don't really have to decide, oh, I want to do this concentration really until your sophomore year. But then in sophomore year, you would take biology, and then junior year, you take biomaterials and biochemistry instead of physical chemistry, and then senior year, you would take physical biochemistry. And so a lot of our students who are interested in more that biotechnology or pharmaceuticals route will take this or will choose this biomolecular concentration as a way for them to take more classes that are more relevant to what they hope to do as a career. Okay, so what's an emphasis area? So you would declare this by your junior year, and then you would complete courses to fulfill this. And so this is kind of your opportunity to pick what you're most interested in going into after you graduate, and just get to take more extra classes that prepare you more for it and really look good on a resume and just be like, yeah, this is what I'm super excited about doing. So these are, the ones above are kind of our list of some of these emphasis areas that we have. I'd say the most popular are probably that biomolecular engineering and the business management. But it's also pretty cool that almost any minor at Clemson will fulfill this emphasis area. So one pretty popular one, for example, is a nuclear minor. I actually picked a biology or minor as my way to fulfill this requirement. So over a third of our undergrads also co-op and then have to do an internship. So a co-op is 3 semesters, so think spring, fall, and summer. And here you would be working in a business or a government agency, and this is kind of a way for you to get your feet wet in industry, or so to put it. It's kind of a way so while you're still a student, you get to have that industry experience like grit on a resume and really gives you some exposure to what you'll be doing after you graduate. So along with this real world experience, it also gives you great interactions with professionals, financial support, all these things. And also our co-op program is managed through the Michelin Career Center, which was actually named the #1 career center in the country in 2016. So about 60% of our undergrads do research, and I would say that Clemson's pretty special in that nearly every faculty will take students. So in contrast to some larger universities, it can be hard to get research opportunities. But here, if you're interested, you can pretty much talk to any professor and they're able to take you as a student. So that's really exciting. So in the department, there are many opportunities. So for example, as you can see from materials, separations, polymers, protein drug delivery, nano, so many opportunities. I actually was able to work with glioblastoma, or brain cancer, it's a type of brain cancer, and that was really cool to do. Also, you don't have to do research in the department, so you could do research in another. So I had a friend who did research in the math department, for example. Also, creative inquiries, or CIs, I would highly suggest you to do one if you're interested in research, as they're kind of a great chance to get your feet wet while you would have a advisor, a faculty advisor, and often a grad student helping you. You'd be working as a team with some other students on a project for a semester. And so it's really collaborative, really fun. It's a pass-fail class, so it's not really stressful, but it's a great way to kind of learn about the field of research and really feel like you're working with a group to accomplish a goal. Freshman year, I actually did one with bioengineering, and that was really fun, and it really showed me that I did want to do research at Clemson. And we also do offer some summer REU programs, so these are kind of a way to earn money over the summer for research, and actually about 10 to 15% of our students actually do research for money at some point during their time at Clemson. And then finally, departmental honors, about 5 to 10% of our students do this. I did it too. And pretty much here you would do this junior and senior year. So first semester, junior year, you would choose a faculty advisor. You listen to lots of different research presentations to help you choose. And then the next 3 semesters, you would get to do research with them on a project. And then your final semester, you'd write it up as an honors thesis. And yeah, you get a medal for it. It's pretty cool, and it's very rewarding. So yeah, highly recommend doing research while you're at Clemson. Okay, so we also just kind of wanted to tell you a little bit about some of these clubs that you could do while you're a student at Clemson. And one of the cool ones is AICE, or American Institute of Chemical Engineers. And we have a couple cool things. It hosts professional and social events throughout the year. Throughout these industry events, these are normally monthly, so you'd often bring your resume and you get really good networking experience with potential employers. Some of our students have even gotten internship offers as a result of these events, which is amazing. And as for social events, we have a pig roast and a shrimp boil each year, and those are super fun, where the faculty and students just come out and yeah, just have a really good time. And then we also have a national conference once a year where some of the students go, some present research, and some of the faculty go too. All right, and finally, if you're interested in studying abroad, and which is an awesome experience, then we do actually offer the second the second lab of unit operations in Denmark. And so you would generally do this summer before your senior year. It's a 4-week program. And I've had many friends do this, and I've only heard really, really good things about the program and their experience in Denmark. So yes, would highly recommend, especially if you're interested in studying abroad. Another opportunity is Engineers Without Borders. So this is actually a club at Clemson, but you would work with other engineering majors, and generally you could work to improve the quality of life in a developing country. So for example, I think one of their projects one semester was to improve the water systems in Haiti, for example. And then after that, some of the students actually get to go to that country and help implement it and see it in action. So super, super cool. And then, of course, there are many other study abroad opportunities, and these are coordinated through our college. And so some of our students have used these to fulfill the requirements for their minors. So for example, I had a friend who had a Spanish minor, and so she was able to study abroad to fulfill some of those requirements as well. All right. And finally, I just wanted to leave you with some department contacts. If you have questions, I would highly recommend emailing Joy. She is the mom of our department, just super caring, super kind, just super amazing. And so, yeah, but we would love to see you at Clemson. Thanks for listening. And yeah, I hope to see you one day as a future Clemson Tiger.